Hey guys, it's Penguin Jumping with Amanda, and this is going to be the kickoff to our chem final. Now the chem final, if you are in 7th period at our school, it is Friday. And so, for those who don't know, our schedule goes that you have 3 hours for 2 finals, so that's 1.5 hours for each, which is basically, for our schedule, a block day period. So Tuesday is 1st and 3rd, Wednesday is 2nd and 4th, Thursday is 5th and 6th, and Friday is 7th and any makeups. 7th period is my chemistry class, so yeah. You got, if today is Tuesday, you have a week and 3 days to study. So for this episode, you're going to need your chemistry study guide, your modern chemistry textbook, and your notes. We will be reviewing all chapters starting with chapter 4 and going back. Chapter 4: Arrangement of electrons in atoms. So what this chapter talks about is the arrangement of electrons in atoms. So this is talking about atom orbitals and stuff like that. This requires the memorization of a couple of formulas, the understanding of the photoelectric effect, the line emission spectrum, so that's the one with the prism, Bohr model, and what else? You get to learn about the modern atomic model, and the quantum model of atoms. You get to learn how to write quantum numbers. You also get to learn about, what else? The full electric configuration, the noble gas configuration, and you get to know the Aufbaum principle, the Pauli exclusion principle, the Hund's rule, and that one other rule that I can't remember right now. But yeah. So, let's start with what was originally posted on the first day of class, which has to do with the Bohr's model, wavelengths, amplitude, and all that other stuff. So, start things off, because our teacher kind of mixed up things, and sometimes my notes say words that haven't been defined, and yeah. So, to get things clear, that word, electromagnetic radiation, this basically means light. So, yeah. The correct definition is the emission and transmission of energy in the forms of electromagnetic waves, and electromagnetic means light, so electromagnetic radiation has anything to do with light. And among these are frequency, wavelength, and energy. So you have a crest and a wave, and that crest is the very top point of the wave. This drawing is of a wave, and for those who are really geeky, this is also a drawing of a sine of x, graphed, obviously. So when that's the crest at the very top, yes, and the line going through it is just where it crosses 0 in the graph you're graphing sine, or it's just where the middle of the wave is. That is called amplitude. We don't really need that right now. But this, so that is actually not frequency. Yeah, I'm doing an overvoice. It's probably better that way. That isn't frequency, that is wavelength. See, there we go. Yay! Wavelength! Go! Me in the past. Yeah, wavelength. So yeah, the point from crest to crest is wavelength. Frequency is a bit like wavelengths, except it's more about time more than length. So wavelength is the distance between identical points on successive waves. So like I showed you, it's like the top of this point to that point. Let's just say. And then frequency is the amount of times that crest thingy passes over a certain point. So let's just say this is the point. You see how this crest is passing over the same exact point multiple times? Well, these crests are multiple points are passing over this crest, this wavelength, this crest to this crest. While this has only one beat passing. And this means that this is a higher frequency, and this is a lower frequency. This, the wavelength, the lower the frequency is. The longer the wavelength, the higher the lower the frequency is. If you want to think about it, yeah, I'm sorry, I have trouble saying frequency. It's my mouth. Just blame it on that. So if you really want a example or a out of context example,